I see this as a multiple-choice question about the LassoLars regression model in Sklearn. We'll assess each statement's accuracy regarding LassoLars' behavior and parameters. Sounds like fun. This sets the stage. We're working with a LassoLars model in Sklearn, focusing on its behavior in high-dimensional data with possible multicollinearity, where features are highly correlated. Sklearn is a popular machine learning library in Python. This section explains the approach. I'll systematically analyze each statement, A, B, C, and D, to determine if it's true or false about LassoLars. Each statement will get its own thorough examination. This is how I'll proceed to make my determination of which multiple choices are correct. I will consider each statement's merits independently before forming a conclusion. The title suggests this is an evaluation of my understanding of the LassoLars model. This is a great way to assess my knowledge and understanding. This section outlines the problem-solving strategy, making it clear how I will approach the task. I will analyze each of the given statements in a structured manner. I'm ready to put my LassoLars knowledge to the test. I'll explain the LassoLars algorithm. It's a clever way to perform regression, especially useful when you have tons of features. It uses L1 regularization, which means it shrinks some coefficients towards zero, effectively performing feature selection. Think of it as a smart way to simplify your model and avoid overfitting. It also uses an iterative method called least angle regression, LAR, making it efficient for high-dimensional data. LAR iteratively adds variables to the model based on how strongly each variable correlates with the data. This refers to assessing how well LassoLars performs in a regression task. We're interested in whether it accurately predicts outcomes and if it correctly identifies important features. The evaluation will be based on the multiple-choice questions. This is a question that tests your understanding of the LassoLars algorithm's characteristics. You need to select the correct statements from a set of choices. I'm happy to help you understand each statement. The instructions for this multiple-choice question indicate that there might be more than one correct answer, so you should select all the statements you believe are true. I see LassoLars as a powerful regression technique. In Sklearn, it cleverly combines the strengths of L1 regularization, which helps you select the most important features and prevents overfitting, and the least angle regression, LAR, algorithm, which is computationally efficient for a large number of features. This is a multiple-choice question testing my knowledge of LassoLars. I need to carefully consider each option and identify which statements are accurate. Let's dive in. I'm being asked to evaluate several statements about how LassoLars works and what its parameters do. I'll need to understand L1 regularization, the alpha parameter, and the LAR algorithm's role. This statement checks my understanding of how LassoLars handles multicollinearity when features are highly correlated. I know LassoLars is better than OLS because of its L1 regularization. Here, I need to think about how the alpha parameter affects the strength of L1 regularization. A larger alpha means more regularization, pushing more coefficients towards zero and therefore leading to fewer features being used in the model. This statement tests my awareness that LassoLars uses the LAR algorithm. The LAR algorithm is designed to be computationally efficient when dealing with many features. This assesses my understanding of when LassoLars is particularly useful. When the number of features greatly exceeds the number of samples, other methods might be more appropriate. I analyze LassoLars, a regression model from Sklearn. I focus on its key features, how it handles multicollinearity, many features are correlated, its use of L1 regularization, which shrinks less important features' impact to zero, doing feature selection, and its efficient algorithm, least angle regression, LAR. I'll break down these aspects for better understanding. I explain L1 regularization. Imagine you're trying to fit a line through scattered points. Ordinary least squares, OLS, tries to get as close to every point as possible. But if points are clustered and some points lie far away and influence the line, OLS creates an inaccurate fit. L1 regularization is like adding a penalty that discourages the line from getting too close to any single point. It makes the model more robust to outliers and reduces the impact of correlated features. It's like saying, don't get too attached to any one point. Look at the overall pattern. I describe least angle regression, LAR. It's an iterative algorithm. The algorithm starts by finding the feature most correlated with the target variable. Then it moves along the direction of that feature until another feature becomes equally correlated. It continues this process, iteratively adding features and adjusting the coefficients until the model fits the data well. It's very efficient for high-dimensional data where other algorithms might struggle. Think of it like building a model step by step. I explain the alpha parameter. This is a tuning knob that controls the strength of the L1 regularization. A larger alpha means a stronger penalty. The model is encouraged to select fewer features and their coefficient values are forced to be closer to zero. It's like saying, be strict about including features. Only use the truly important ones. A smaller alpha allows more features to contribute. This helps to find the sweet spot between model complexity and predictive performance. I present a multiple-choice question to test your understanding of LassoLars' behavior and parameters in the context of linear regression on high-dimensional datasets. You will need to identify correct statements from incorrect ones. I evaluate the LassoLars model. LassoLars is presented as the subject of a multiple-choice quiz. The quiz tests your understanding of the model's capabilities and limitations. This means you should know how to apply it correctly. I'm assessing the LassoLars regression model, a type of linear regression that's especially useful when dealing with many variables and potentially redundant information. Think of it as a smart tool for analyzing complex datasets. We'll be tackling a multiple-choice question that tests your knowledge of the LassoLars model's characteristics and how it behaves in different situations. Get ready. We're using the LassoLars model from the Sklearn library in Python. This library provides tools for machine learning, and LassoLars is a specific algorithm. It's useful for situations where you have lots of input features and possible overlap between those features. This statement claims that LassoLars is better at handling multicollinearity, which means that the input variables are highly correlated. LassoLars, unlike the standard ordinary least squares, OLS, method, does this well. The alpha parameter is the tuning knob for LassoLars. A larger alpha means more aggressive shrinkage towards zero. It leads to more variables being discarded and a simpler model. LassoLars utilizes the least angle regression, LAR, method. LAR is an iterative process, making LassoLars computationally efficient, especially when dealing with lots of variables. This is about a scenario where the number of data points is smaller than the number of input variables. While LassoLars can handle high-dimensional data, it's not ideally suited for this extreme case where there are far fewer data points than variables. This section introduces the topic. We'll be evaluating the LassoLars model, a regression technique. This is a multiple-choice question. I'll need to choose the correct statements about LassoLars. This question will test my knowledge of LassoLars and its properties. I need to understand how LassoLars handles multicollinearity, when multiple variables are highly correlated, regularization, reducing model complexity, and high-dimensional data, many variables. This statement claims that LassoLars is better at handling multicollinearity than ordinary least squares, OLS, a standard regression method. I'll need to check if that's true. This statement describes the role of the parameter ALPHA in LassoLars. ALPHA controls how much LassoLars shrinks the coefficients of the variables, L1 regularization. A higher ALPHA means more shrinkage and more feature selection. Some features might be eliminated completely. This statement says LassoLars uses LAR, least angle regression, an iterative method, which is faster for datasets with many features. I should check if this is a core part of LassoLars. This statement suggests LassoLars works exceptionally well when you have far fewer data points, N, than variables, P. This is often a challenging scenario for regression models. I'll need to see if LassoLars excels in such conditions. This simply indicates that I must select the correct answers from the options provided earlier. This is the title of the problem statement, indicating that I'll be focusing on the behavior of the LassoLars model when dealing with datasets that have lots of features and possibly some redundant information between those features. It sets the stage for the multiple-choice questions that follow. This simply tells me the format of the quiz. Multiple choice. I need to select all the correct answers from a list of options. I'm using a specific type of regression model, LassoLars from the Scikit-Learn library, to analyze data with many features. Some of those features might be related, causing problems for a regular regression method. The question asks me to identify true statements describing LassoLars. The "alpha" parameter controls the strength of regularization in LassoLars. Think of "alpha" as a dial. A higher "alpha" means more aggressive regularization, forcing the model to use fewer features. That's because it pushes some coefficient estimates to zero. LassoLars uses a clever algorithm called least angle regression or LAR. It works iteratively, step by step, which makes it good for datasets that have many features, which often makes calculations very expensive. This statement is testing my understanding of whether LassoLars works well even when I have many more features than data points. It's important to know that while LassoLars can handle high-dimensional data, it's less reliable when I have far fewer data points than features. This simply indicates that the following statements are the options from which I must choose the correct answers.